Hello. We're going to now start our journey into Chapter 4. And Chapter 4 is about designing studies. It's about experiments and samples and observational studies and surveys. It's about collecting data. We've looked at what you do when you have data. How do you organize it? How do you graph it? How do you make numerical summaries of it? We haven't talked about how you get data. And getting data is one of the most difficult things you can do in statistical analysis. Really hard to get good data. There are 3 sections of Chapter 4. This video is going to be on samples and surveys. Kind of the process that we go through here is looking at a large population and taking a small sample from that population, finding out information about that sample, so collecting data from that sample, and then using that data as a representation of the larger population and making some sort of an inference about the larger population. So the population is the entire group we're interested in, and the sample is the specific people or the specific part of the population that we collect data from. Now, what usually happens when we do this, in most of our data collection throughout life, even day to day, you think about your own life, you collect data all the time through conversations with people, by asking people their opinions on stuff. This is data collection, really, in its most raw. Most of our data collection is done through convenience samples. We ask people who are near us. We ask people who are sitting next to us at lunch. We ask people who are in our family. We ask people that are convenient to ask, and that's called a convenience sample. And that's a fine way to collect data in one's life, to kind of get an idea about what's going on. But it actually really creates a large bias, typically. Because when you do that, the people that you ask are probably, in many ways, most of the time, are similar to you, right? If you ask people in your family, they have similar backgrounds to you. If you ask people in your class, they're taking the same class as you. You ask people on your sports team, they have that background. And this can lead to something called bias. And bias is the idea of systematically favoring a certain outcome. Now, what does this mean? Well, I'll give you a couple examples. Let's say, for instance, I was interested in how quickly the average student in my high school runs the mile. And I decide, well, I'm at track practice one day. I'm just going to time a random sample of track athletes in the mile and see how it goes. Or I'm going to ask them. I'm going to randomly ask 10 kids what their mile time is. Well, there's a couple of issues with that. But one of them is that if I choose to conveniently ask the people that I'm coaching, whether it's the track team or whether it's the cross-country team or the soccer team, I'm choosing people who are already athletes, who are already doing stuff physical. So it's likely that those people are going to have a faster mile time than the average student in the school. And because of the way with which I collected my sample, because of the systematical way I collected my sample, which is choosing the people that are on the sports team, I favored a time that was faster than normal. So it systematically favors that outcome. Another idea is, if I was interested in if people liked to play video games, okay? And let's say to do this, I went to a Comic-Con convention, all these comic book people. Well, it's probably more likely that the average comic book reader is a video gamer than not. So I might systematically favor people saying yes to that. So this idea of systematically favoring a certain outcome is called a bias. And we want to try and avoid bias. There's a lot of ways to actually create bias. It's actually fairly hard to avoid bias. Another way that we create bias, and this one's a little hard to know which way it goes, is through voluntary response samples. This is when you just let people decide if they're going to take a survey, or you let people call in and tell you their opinion. Maybe it's a talk show, radio, and you say, call in and tell us what you think about this new tax law, or call in and tell us what you think about using, governmental dollars to build a football stadium. In a situation like that, you're going to have people who are really excited about the football team or call and say, I think it's a great idea and we should support our team. And then other people who are not maybe that excited about the football team and think it's a waste of tax dollar money. And you don't get a lot of people in the middle, because the people in the middle don't take the time to respond to the surveys. So you got to be aware of this issue when you're doing a survey, that there's a voluntary response is going to create people with strong opinions to give you their opinions. So we've talked a little bit about ways that it's sampled poorly. So what are some ways that we can sample well? That's the next question, right? So clearly there's issues with convenience sample, voluntary response sample, and creating bias and favoring outcomes over the others. How do you do this without having that happen? Well, what we'd like to do is we'd like to take a random sample, and ideally, in most cases, what's called a simple random sample. A simple random sample is sometimes abbreviated as an SRS, and it is a sample of a certain size. So if we want to sample 30, it's a sample size 30 that consists of 30 people or 30 individuals, in which every possible group of 30 individuals is equally likely to be chosen. And that's more than just the idea that every person is equally likely to be chosen, but every possible group is equally likely to be chosen. And we'll kind of explore that a little bit later with homework problems and things like that. But that's the idea of a simple random sample. And one of the ways that we learn to take simple random samples is by using a table of random digits. So lots of times, statistical books, or even you can have computers print out table of random digits, and they're really actually called pseudo-random, because true random is really hard to come by. And there's even theories that there's no randomness in the world. But pseudo-random, and that's what we'll go with, and we'll call it random, we'll consider it random for the purposes of our course, is where any of these numbers in this table are equally likely to pop up. So a table of random digits consists of digits from 0 to 9 that are listed in a table, and you use them to choose events to occur or to select people for a survey. The steps here is you're gonna give each member of the population a numerical label of the same length. So give everyone a 2-digit number or a 3-digit number, and you'll see that in the next example. And then you'll read through the table using those groups of digits. So if it's 2-digit numbers, you read 2 digits at a time. If it's 3 digits at a time, until you find enough people for your sample. As an example, that was a little abstract, absolutely. So as an example, here's an example. In this circumstance, there are 28 hotels, and we want to survey 4 of them. We want to take a random sample of 4 of them just to kind of see how things are going. So step number 1, we would give all 20 of these hotels a digit. Okay. Now, for this to go well, all of them have to get a 2-digit number. So we can't label them from 1 to 28. We have to label them from 01 to 28. Okay? Because if we label them from 1 to 28, then when you get to here and you see those first digits, 69051, we don't know if that 6 is a 6 or if it's a 69. But if everything is labeled with a 2-digit number, then we read the digits from the table 2 at a time. So that first 2 digits is 69, and the next 2 digits are 05. So that's where the 5 comes in, if a leading 0 is in there. So after we label them all with 2-digit numbers, okay, then we go through the table, and we take chunks of 2-digit numbers, and we kind of write them down. And what we're looking for is we're looking for 4 hotels, so 4 unique, so they need to be unique, 2-digit numbers that also must be within range. The range is 01 to 28. So if we get numbers that are greater than 28, we just cross them off. And you can see the first one is crossed off. The next 2 are within range. The 48 is crossed off. And then the 17 is within range. Then the 87 is crossed off. And then you see the 17, and that's not starred because that is not unique. We've already gotten a 17, so we can't survey that hotel again. And just keep going, crossing off numbers that are out of range and skipping ones that are non-unique until you finally get the last number that's unique and within range. So the phrases unique and within range are important. Okay? They need to be a new number, and they need to be within the range that we're looking for. So once you have these 4 numbers selected, you can tell which hotels you're going to choose. Now, that is one type of random sampling method. There are actually 2 other ones that we're going to dive into a little bit in this book and in this course. What is called a stratified random sample. So in a stratified random sample, we break the population into groups that are similar or somewhat homogeneous, and those groups are called strata. And then within each strata, we take a random sample or a simple random sample from within each strata. So in a stratified random sample, you actually take multiple simple random samples from each of the strata. Okay. I'm going to go to this one first, and then we'll kind of put them together. Now, the next one and the last one we're going to discuss right now is called the cluster sample. So a cluster sample takes place in situations when it's kind of difficult to do a simple random sample or a stratified random sample. It might be done with trees in the woods, or it might be done with plots of land, which maybe you're looking at the corn. There's just so many things that it's hard to number them. Because with stratified random sample and simple random sample, we really need to number every individual. Some things that's too difficult. So in a cluster sample, what you do is you break the population into groups that are somewhat ideally heterogeneous. So they're a mix of all sorts of different people in every group. And then once you've broken into these groups, okay, then you randomly choose a couple of the groups, or a couple of what's called the clusters. And then you ask every single person in that cluster, or every single individual in that cluster, or every single unit in that cluster, you do the survey or collect the data about those things. This example here will help us understand the difference between a simple random sample, a stratified random sample, and a cluster sample. In this case, if you imagine yourself sitting in an auditorium, and in this particular auditorium, the front of the auditorium is filled with seniors, the next rows are filled with juniors, sophomores, and then the freshmen are sitting in the back. So the seniors have numbers 1 to 200 chairs, the juniors get 201 to 400, 401 to 600, and 600 to 800. So there's 800 students in this auditorium. Now, if we wanted to choose 80 of them, if we did it with a simple random sample, what we'd simply do is we'd number them all from 001 to 800. We'd use a table of random digits, and we'd look at 3-digit numbers over and over again until we found 80 3-digit numbers that were unique and within range. That would be the people that we'd survey. If we want to do a stratified random sample, again, stratified random sample means break the population into strata. The strata have to be similar by some trait. So in this case, the most likely way you break it is you break them into their grades. So the 12th graders would be one strata, the 11th another, and the 10th and the 9th another. And then within each strata, we'd randomly sample 20 students. So 20 students would be randomly selected from each strata using the methods of a simple random sample. That would give us 80 students and 20 from each grade, which in some cases you want that. You want stratified because you want to make sure you got a good representation of each of the populations that you're interested in. The last way is this cluster idea. Now in the cluster sample in this case, one of the ways you could do it is if you look at these seating charts, right? You see that behind seat number 1 is 21, and behind seat 21 is going to be 41, and then 61, and then 81. You could take that whole, well, let's call it column of row of chairs, and we could say that is cluster number 1. And then cluster number 2 would be seats 2, 22, 42, 62, 82. So that'd be cluster number 2. And then what you do is now we have 20 clusters, okay? Then you just randomly select a number of clusters. So if you look at this, so there's 20 clusters, right? And there's 800 students. So there's 40 kids in each of these clusters. So you just randomly select 2 of these clusters. So you'd randomly select a digit between 0, 1, and 20. And once you've done that, you select another one. And once you have 2 unique digits between 0, 1, and 20, you just take those 2 columns of seats. Now, the reason this is a good cluster sample is because those columns would be somewhat heterogeneous because you're going to get some freshmen, sophomores, juniors, and seniors in each of those clusters. Actually, an equal number in this case. So that's called a cluster sample. And then once you've selected that whole column of students, every single person down that column would be asked the question, or you'd find the information out about them. So that's the last time called a cluster sample. All right. Now, we're going to use these sampling techniques to try and create an inference, to try and make an educated guess about the population. And we're going to try and eliminate bias by taking a simple random sample or some sort of random sample. But even if we've eliminated bias through the ideas of probability, through the fact that sometimes when you take a sample, you get a different group than I might get, just through that random deviation, there's something called a margin of error. So let's go back to the idea of finding out how fast students are at our school. I might randomly select 20 people and ask them how fast they run the mile, and you might randomly select 20 people and ask them how fast they run the mile. The average I get will likely be different than the average you get, not because either of us did it poorly, but just because there's random deviation. It's like flipping a coin 20 times. I might get 11 heads, you might get 9. That's normal. That's called the margin of error. And the margin of error really is the word error is unfortunate that it's used here. It's really kind of the margin of random chance, because random chance kind of moves our needle back and forth a little bit, particularly if we take a small sample size. The larger your sample size, the more accurate that's going to be, and the less error you're going to find, or the less deviation due to chance you'll see. Now, when we did surveys, we talked about things that created bias. These are all ways that can create bias that are listed here. And you want to know all of them. You don't necessarily have to memorize all the terms, but you want to understand the ideas. So undercoverage occurs when the way with which you've selected the sample precludes or makes it so some people are not able to be selected. Okay? So if I'm interested in how people feel about the food of the dining hall, okay, and I randomly select people as they walk in to eat, anyone who doesn't make it to the dining hall to eat that day is not going to be included in the survey. And that's an undercoverage error, because they were not in the process of being part of the sample. That's called a sampling error. Okay. Now, convenient sample oftentimes create undercovers. That's a sampling error. Voluntary response oftentimes create undercovers. That's a sampling error. Now, non-response, this is not a sampling error. So the next three things actually are: you might have did a great job selecting the people that were going to be in your survey, but then after you selected them, non-response means they just didn't respond. You asked them repeatedly, can you please answer the survey? And they just don't. Maybe email them, maybe talk to them, maybe they say, no, I'm unwilling. That's called non-response. They just don't respond. Okay? Maybe because they refuse to, or you can't reach them. Now, response bias, this is where people actually don't tell the truth. And this particularly happens when they don't feel like they want to tell the truth. You know, maybe it's something that's sensitive. Maybe I, as your teacher, ask you about drug use or ask you about sexual behavior. Now, that's typically going to make you feel uncomfortable. So you may respond in a way that you think is what you should say to me instead of what the truth is. Now, interestingly enough, response bias occurred in a fairly recent election. So in the 2016 presidential election in the United States, all of the surveys indicated that Hillary Clinton was going to win the election, when in fact Donald Trump won. And this is attributed actually to response bias, because when people called and asked the likely voters who they're going to vote for, many of them felt uncomfortable. Well, not many of them, but a certain population of them felt uncomfortable saying that they were going to vote for Donald Trump because of many of the things that he was saying and how provocative they were. So because of this, almost every survey was wrong. Almost all the people who were determining who was going to win were incorrect. And that was due to response bias, people just not answering truthful about what they were going to do in that election. And the last one that we're going to talk about here is called wording of the question, which creates bias. So this is where someone words a question in a way to try and get you to answer a certain way. Maybe I'm a real advocate of people being able to own guns, and I say, okay, you know, if you believe in the Constitution and if you are a true citizen of the United States, the Second Amendment says we have the right to bear arms. How do you feel about people carrying concealed weapons? So if I lead with that, I might be making it more likely for you to say you feel fine about it. You feel like people should be able to carry concealed weapons. But I could word it a different way, right? If I wanted to sway you a different way, I could potentially say, given all of the violence due to guns and all the deaths, all the homicides because of gun violence, do you think people should be able to carry concealed weapons? Now that words it a completely different way. So because of the wording of the question, it might swing people to answer the question one way or another. And this again creates a bias. All right, so this is the end of 4.1. And you can kind of see in this summary here, kind of what we went through. We talked about surveys, talked about how to sample well through random sampling techniques, talked about random sampling through simple random samples, stratified random samples, and cluster samples. There are three types of sampling techniques that we talked about. And then we talked a little bit about how Sampling poorly can lead to bias, and there's a bunch of different poor sampling techniques: voluntary response, convenience samples, things that create undercoverage, non-response, response, wording bias. So that's it for this lesson. Next time we'll talk a little bit about experiments.